This is a reminder, Class Connect sessions are recorded and distributed for learning purposes that are listed here. As always, be respectful, appropriate, and participate, but please don't share personal information during the class for your own security reasons. All right, so on the whiteboard today, I want to know what is one thing that you're going to do today to have fun. Go ahead, type on the board or tell me in the chat box one thing that you plan on doing today in order to have some fun, right? We talk all about working hard, we talk about meeting our goals and developing good habits, but sometimes we just need to let loose, have a little bit of fun. There's no shame in that. That's a good thing, a healthy thing. So go ahead, tell me on the board, what are you going to do today to have fun? Let's see here. Efren, you said in the chat box you were playing Fortnite, game mode of John Wick, had to be in squads. One kid that was 6, he was 6 years old. He thought you were going to lose, but you won the game. And he starts, oh no, sorry. Are you saying he was a level 6? Is that what you're telling me? It does sound pretty epic. Caleb, it's raining. I know. Yeah, the yucky weather out here makes it more difficult to have as much fun. But we can still do fun things, right? Oh, he is 6. That's crazy, Efren. Dolly, you said put together a banana, dry fruit seeds, and peanut butter for your lunch or for a snack. That sounds very tasty. I love all of those things. Looking good. Go ahead, keep on answering up on the board for me. Looking good. Everybody, make sure you open up your ticket as well. Let's see here. We got some other students here. Hi, Isaiah, Oscar, Michelle, Andres, Noah. Noah, good to see you. Hope everything's going well. Got your email or your text, so definitely let me know if there's anything else we can do to help. All right, looking good. I got lots of answers up here. Let's see who I've got on the board. I've got Shoshana and Oscar, Amanda and Letty, Dolly, Efren, Israel, Amanda on the board. Hi, Donnie. Hi, Blossom. All right, I'm going to go ahead and start going over what we've got up here. So, Israel, you said you're going to hang out with friends after class. It's been a really long time. That's great. Always good to see your friends. Game day. I know we're missing so many game days. Yeah, so today is not a game day. Today is a lab, but we will eventually have a game day, so that will be fun. Shoshana, you said you're doing some Zumba. Oh my gosh, that's both fun and productive, right? Getting some exercise in. Hanging out with friends, Oscar, awesome. Dolly, you said you're going to draw and give your cat some kisses. That always makes me happier, right? Eating a churro currently, Efren, that makes you happy. Makes sense. That's a lot of fun. Dree, you're having a movie night. What movie are you planning on watching or movies? Letty, you said you're playing basketball. And Amanda, you said probably going to read a book, have some time with your mom and sister. Well, it sounds like we're going to have some fun hanging out with people that we care about as well as doing some fun activities. I like that. All right, looking good. Hold on, I'm missing something. You said one of them is going to the Philippines for good. Oh no, so the last time you're going to be able to hang out with her. Oh, I'm so sorry to hear that, Israel. Well, as you get older, the nice thing is that you begin to be able to travel more. And so maybe there's still a chance you'll see your friend later on in life, right? Going to dinner for your mom's birthday, Jacob. Oh, that's so nice. Yeah, looking good. All right, everyone, let's go ahead and jump in. Thank you for telling me what you're going to do to have fun. Definitely recommend if you're stressed out, having a hard time, definitely take just even an hour throughout the day to just try to find something to do for fun because remember, you have to have balance in your life, right? So we work hard, but we also want to have fun as well. Cool. All right, so go ahead, open up your ticket, give me a green check when you've got it ready to go. I already have 7 people who did that for me. Thank you so much. Password is in the chat box along with the links for today. Oh yes, Kevin Hart is quite funny, Efren. Looking good. All right, looks like everybody is able to get in. Let me know if you're having any issues at any time though. So we only have 20 days left of school. Remember guys, tomorrow we are officially in the teens. All right, so tomorrow we'll officially be down to 19 days left of school, going by very, very quickly. Hopefully you're pretty happy about that. So again, yesterday, I'm so sorry. I did have state testing on Tuesday that then I had to go back and retest the student on Wednesday as well, which was not what I had planned, but unfortunately that's how it worked out. So I wasn't able to teach classes yesterday. So again, hopefully you just used yesterday to complete anything that was missing or retake anything that was failed. But today we've shifted things forward. So today we will actually do our lab. Smiley faces, everyone, if that makes sense. Again, we are shifting things forward a little bit. Perfect. Okay, awesome. Let's go ahead and take a look at our unit description, right? We've been talking all about mixtures and solutions. Today, our lab is going to be taking a look at solubility. So we're going to design an experiment based on a hypothesis and graph and analyze that resulting data. And then specifically, our experiment for today is taking a look at how a temperature affects the solubility of a solid solute in water. Okay, so we're designing an experiment just like we always do on lab days, but today we're taking a look at the relationship between temperature and solubility. Okay, so that's our question for today. How does temperature affect solubility? And this is the kind of map that we'll be going through as we do our lab. So first off, we're going to use our 5 senses to make some observations in the chat box. Really quick, what are the 5 senses? Start off with this one on the left. What is that? Go ahead, tell me in the chat box. Everybody wake up. We know these answers. This gives you a good chance to participate. Make sure that you're here. Yeah, so we've got sight. The next one is then what? Take a look at that yellow one. Yes, that's going to be hearing. And then yes, our middle one here is smell. Absolutely. Those last two, what are those last two? We've got the red one and the green one. Yes, taste. Probably don't taste the computer right now, but you'll be able to use your memory of taste, and then touch as well. Perfect. Okay, so we're going to use some of our 5 senses to make some observations. It's a minute-long video. Give me a green check when you finish watching it. Let me go ahead and grab it really quickly. It's going to be up on the whiteboard, and I'll put it in the chat box as well. Here we go.
We all feel like drinking something cold, and if the drink is sweet, it is so much the better. Today we will examine whether sugar dissolves more in cold water or in hot water. For this, you take 2 glasses. Fill one with cold water and the second with hot water. The right glass has hot water and the left glass and the middle glass is cold water. Take a sugar cube and put a sugar cube each in both the glasses. Then wait and see in which glass the cube dissolves first. You will see that there is much more activity in the hot water as compared to cold water. The sugar cube will dissolve much more quickly in hot water. If you don't have sugar cubes, you can repeat this experiment with ordinary sugar.
Looking good. All right, everyone. So let's think about this. Have you ever had iced tea versus hot tea? Tell me which one is easier to dissolve more sugar in. Tell me in the chat box. Tell me which one is easier to dissolve more sugar into. Yes, we absolutely saw this in the video as well, right? So you probably know this from personal experience as well as in the video you saw in hot water or in hot tea. It's much easier to dissolve your sugar. For example, when you have iced tea and you try to dissolve your sugar in there, it doesn't taste very smooth. It ends up tasting very gritty because it takes so long for that sugar to dissolve. Smiley faces, everyone, if that makes sense. So based on our previous experiences and observations, as well as what we saw in the video, hot liquid, right? Hot liquids definitely dissolve sugar a little bit better, dissolve it faster, dissolve a little bit more. All right, awesome. Getting some smiley faces. Yes. Yes, it's going to be very, very sweet, right? Awesome. All right, everyone. So that's what we need to take a look at here, right? So we saw that in hot water, what happens? Do we have more sugar dissolving or less sugar dissolving? Tell me in the chat box. In hot water or in hot tea, what happens to the amount of sugar that we can dissolve? Yeah, we saw that it dissolves faster and there's more that's dissolving, right? Awesome. And then in the cold water or cold tea, iced tea, tell me, what do we see happening with our sugar? With the amount or speed of the sugar that's dissolving. Yeah, there was definitely less sugar dissolving and it dissolved much slower, right? So in terms of, oh, I should actually type the word sugar, right? Awesome. Cool. All right, so today what we're going to take a look at is we're going to take a look at this really specific relationship between temperature of a liquid, in this case it's going to be water. So we're going to take a look at temperature of water and how it's related to the solubility of a solid solute. Okay, so those are a lot of S words. So remember, solubility means the ability to dissolve, right? How much can dissolve. Smiley faces if you remember that. So solubility means how much can dissolve. All right, so this was from Wednesday. All right, how much can dissolve? Dorian, there was no password yesterday. We did not have live classes based on what I told you earlier in class because I had to test students yesterday for state testing. Solid solute. All right. So remember, solute is the stuff that's getting dissolved, right? So this is the stuff that's getting dissolved. And specifically, we're talking about solid ones like sugar or salt or Gatorade powder. Okay. We're not going to be talking about gaseous solutes because we'll take a look tomorrow. Gaseous solutes like carbon dioxide in your soda act a little bit different. Okay. Thumbs up, everyone, if that makes sense. So we're looking at how much of a solid stuff can dissolve. How much of a solid substance can dissolve. Excellent. All right. Looking good. So our observation is when water is hotter, more sugar seems to dissolve in it. We're asking, how does changing the temperature affect the solubility of a solid solute, right? We have to specifically say solid. And we're going to make our hypothesis right now. So remember, hypothesis is our educated guess or the kind of answer that we're guessing for the question up here, right? For this question up here. So tell me in the chat box, right? If we increase temperature, what do you think is going to happen to the solubility or the amount that can dissolve of the solid solute? Is it going to increase or decrease? If we increase temperature, what's going to happen to the solubility or amount that can dissolve? Amount that can dissolve. So hotter liquids, what happens to how much solid solute or sugar can dissolve? Does it increase or decrease? Then solubility will, what do we think? Looking good. I got answers from Ephraim, Israel, Caleb. Do we agree? Do we disagree? I need more participation in the chat box. Remember, reinforce your own learning. Doesn't help you if somebody else is answering because they're not the one that's learning for you. You need to be learning. Awesome. Then solubility is definitely going to increase, right? So more will dissolve. Okay, give me a thumbs up if you feel good about that. So by increasing temperature, the solubility of our solid solute is going to increase, meaning more is going to dissolve. Excellent. All right. Thank you, Caleb. Thank you, Ireland. Thank you, Israel, Ephraim. Looking good. Thank you, Noah. Thank you, Jackie. Awesome. Okay, everyone. So that being said, we're going to go ahead and send you the lab report right now. So if you can't have two windows open at once, I recommend just have your lab open for now, and then you can go back to your attendance ticket at the end of class because we'll just resend it out at the end of class. So just have your lab open, or if that still doesn't work, then be ready to take pictures. All right, go ahead and give me a green check once you have that lab open. Let's see here, Mr. Alch, let's go ahead and send out those lab links. And then everybody else, go ahead again. And once those lab links are sent out, give me a green check once you've got it open. Oh, looks like some of you already opened it through your course. Looking good. There we go. All right, Mr. Alch just sent out those links. So go ahead, open up your lab and let me know that you have it open, or give me a green check if you're ready to take pictures. So you either have a phone to take pictures or you have the ability to screenshot on your computer. Awesome. Thank you, Amanda. Thank you, Dolly, Ethan, Ireland, Israel on top of it. Thank you, Michelle, Miguel, Noah, Orlando. Awesome. Thank you, Parker. Green checks once we have our lab open. Got about half of you ready. Just want to make sure I'm not leaving anyone behind. Again, we are going to be going over some of the answers in class as well as how to do your data collection today. So I want to make sure you're ready. All right, looking good. Let's keep on going here. Okay, so our hypothesis was if the temperature of water increases, then the solubility of a solute will also increase. That's what we predict, right? Hotter water, more solid will dissolve. Okay, so that being said, we need to figure out for question number 1, what is the independent variable in our lab and what is the dependent variable in our lab. Again, please do not write the definition. Okay, I want to actually know what it is specifically in this lab. All right, so first off, the independent variable in our lab is always what we change on purpose at the start of our experiment. So what are we able to change? Are we able to change the temperature of the water or the amount of solid solute that's going to dissolve? Go ahead, tell me in the chat box, what can we control, temperature or dissolving the solute? Tell me in the chat box. If you need a hint, take a look at the beginning of the hypothesis. Beginning of the hypothesis is always our independent variable. Looking good. Got answers from Israel, Ephraim, Dorian, Ireland. Yeah, so the temperature of the water is our independent variable. So we're going to be changing temperature of the water, and we'll be using degrees Celsius for that. Okay, smiley faces, everyone, if you feel comfortable with that. Again, temperature of the water, that is our independent variable. Now, our dependent variable, Remember, our dependent variable is what we're actually measuring at the end, or the final result of our experiment. So take a look at the end of our hypothesis and tell me, what is the final result, the end thing that we're measuring in our lab? Go ahead, tell me in the chat box really quickly. So we're now talking about dependent. Tell me, what do you think? Awesome, I got an answer from Israel. Efren, the question is, what is our dependent variable, what we're measuring at the end of our experiment? The result. Take a look at the end of your hypothesis. That's your hint for what we are measuring at the end. Awesome, thank you, Ireland. Thank you, Efren. Let's get a few more answers in there in the chat box. Awesome. I see Caleb typing, Miguel typing, Noah typing. Yeah, so it's going to be the solubility of the solid solute. So in this case, when we talk about solubility, we're going to be finding the maximum amount of solute that dissolves. Okay, so this is how we're measuring solubility, and we're going to be measuring this in grams. Okay, so the maximum amount of the solute, whatever solid solute I have, that dissolves. Okay, one more time, smiley faces if that makes sense. So our starting is the temperature, our ending is the amount that we can dissolve. Excellent. All right, so this is going to be number one. So this first one should go in for independent variable, and the second one should go in for dependent variable for number one. Give me a green check when you have it saved, or you can take a picture and give me a green check, but you have 1 minute to get that done. Ready, set, go. All right, waiting on some more green checks. Andrea, Andres, Ashton, Damien, Dusty, Donnie. Yes, totally understand, Noah. Yeah, let me know if there's anything I can do to help. Don't worry about yesterday. Yesterday we didn't have live class because I was testing a student, so don't even worry about yesterday. You didn't have any new assignments yesterday. All right, waiting on green checks from Dusty, Dree, Dylan, Elias, Jacob, Jackie, Jasmine, Jessica, Caleb, Cash, Letty, Blossom, Yolese, TJ. Green checks for number one. Again, I'm literally helping you with the answer for number one, so let's make sure we're focused. Let's make sure we're typing this down. Going to give you another 5 seconds, and then we're moving on. And if you miss it, you will have to watch the recording later. Looking good. All right, everyone, we are moving on. Let's go. All right, so this is going to be a virtual lab, all right, meaning that you will need to gather your own data. The link is provided for you in question number 2 of your lab. Just like always, whenever we have a virtual lab, you can see that link down there. I'll show that to you in a few moments. I do want to remind you that if you get this warning that says this Adobe Flash warning, do not press the red button. The red button does not help you. Instead, you want to press what's right above it. It'll either say activate Adobe Flash or run Adobe Flash. Smiley faces, everyone, if that makes sense. Again, don't press the red button. The red button is not actually helpful. All right, it's the white stuff right above it that doesn't look like a button, but it is a button, and I don't know why they hide it, but that will allow you to use Adobe Flash. Okay, so this is what your lab's going to look like. You will see that you have 5 different chemicals that you can choose from. You will not be allowed to choose the first chemical because the first chemical is the one that I am going to use as your example today. So you will not be allowed to use the first one, but you can use any of the other 4. Okay, Efren, you don't have to open it right now because I'm going to demo it for you first, and then if we have time, you can go ahead and work on it until the end of class. All right, so you can see here's our 4 different chemicals you'll be allowed to use. There are 3 different amounts that you can add. You can add 1 gram at a time, 10 grams at a time, or 25 grams at a time. This right here keeps a count of how much you've added. If you add too much, you can click undo. And then you can see down here, these are the different temperatures that we can set the water at. So there's 100 milliliters of water. We can set it at 0 degrees, 20 degrees, 60 degrees, or 100 degrees. Smiley faces if this setup makes sense to you. All right, again, I'm gonna actually demo it for you, but I wanna make sure no one's confused about anything they see up here so far. Awesome. All right, looking good. So that being said, what you are going to be doing is you are going to be setting the water at the 4 different options possible. So the only options are 0, 20, 60, and 100 degrees. So at each option, you're going to set it at that temperature, and then you're going to add solute until no more solute will dissolve. So that's going to be the maximum amount of solute that you can dissolve. That's what you're going to be filling into your data table, which again, I will be showing to you in a moment. Now, I want to remind you again, you cannot use the first chemical. Okay, so the first chemical is ammonia chloride. You cannot use that, NH4Cl. All All right. Efren, it should be pretty exact. All right. I'll show you exactly how to do it in just a moment. Okay. So what we're going to do is, again, you do need a Google account. Make sure you're logged in so that your template works. All right. The template is in question number 2. You'll click on it. It'll ask you if you want to make a copy. You will say yes. You'll type your name into the title. We'll type in our data. There is a new thing where you do need to fix the trend line to make sure it's correct, and then you'll get your shareable link, copy and paste that into number 2. Don't worry, I know that was really fast. Again, I'm going to show it to you in just a moment. Now, what I recommend right now is please just watch the instructions. I will explain that in a moment. Don't worry, Efren. Please just watch the instructions and wait for me to finish the instructions, because I'm afraid that if you try to do it at the same time, you'll get lost and then you'll ask me 500 questions, which will confuse all of the other students. So please, let's just have everybody watch together for now. Hold questions unless it's like something super urgent. Try to hold questions until the end. That way we're not confusing anybody else and we're being good classmates. Smiley faces, everyone, if that makes sense. Okay, so let's work together to make sure that everyone feels comfortable with this. Awesome. All right, everyone. So let me go ahead. I'm going to open up the lab here. Give me one moment, and then I will share this with you. All right, so I'm going to actually share this desktop with you guys. All right, Dolly, just like always, you can actually go into your course page, go to Unit 6, and then go to 6C from there, okay, or 6B from there, okay. Okay, that might just be a computer issue then, so I would recommend just try it again later, and for now, just watch the instructions. If it's still not working, you can email me in like half an hour and see if it's okay. Perfect. All right. So at this point, everyone, we have answered question number 1 together, right? So we talked about, sorry, let me blow this up. We talked about our independent and dependent variable. Make sure those are filled out here already. Now we're going to go ahead and work on question number 2. And so you need to open up both of these links. So there's the virtual lab as well as where you are going to actually be typing in your data. Okay, so I'm going to click both of these. All right, again, if it says run Adobe Flash, you can click run Adobe Flash and allow it. And that will allow this to open up. And then you also, again, need to open up your second link, which is where you're going to actually be putting your data. All right, so we're going to open that up, click make a copy. Please, 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 if you can, remember to type your name at the top, right? So where it says type your name here, please make sure you actually click in there and type your actual name. Otherwise, it gets very confusing for me as I am grading those. Okay. All right. How are we doing so far? Give me smiley faces if you feel good about everything I just talked about. Confusion faces if you're having any issues so far. Looking good. All right. Got some smiley faces. Love it. Looking good. All right. So those are the 2 links that I should have open. So here we go. What we can see here is we can see 5 different chemicals. All right. Sorry. Let me blow these up a little bit. So we can see 5 different chemicals right here. Okay. So NH4Cl, BaOH2, so barium hydroxide, copper sulfate, CuSO4, potassium chloride, KCl, or sodium nitrate, NaNO3. Okay, so these are the 4 different compounds that you can have. Now, again, you are not allowed to use the first one. Okay, so I tell you here in the blue box here, do not use NH4Cl. Okay, that is the one that I am using. And so you cannot use that one because then you'll have the same data as me, which is cheating. Okay, so what you'll do is you're going to choose one of these 4. So choose any of these 4, and then you're going to type in which of those that you choose. Okay, so again, my example, I'm going to use NH4Cl. So I would type in NH4Cl. But again, you guys should not do that. You should definitely choose a different type. All right, so again, I'm going to type here, don't use this one. All right, smiley faces, everyone, if that makes sense. All right, so my example is NH4Cl, but everyone else, do not use that one. Use any of the other 4. Perfect. Okay, so what you are going to do is you're going to set your temperature at 0 degrees. Okay, so I'm going to set this at 0 degrees. Which it's already set to. And I'm going to begin adding compound to see how much will dissolve. Now, if you want to, you can add it 1 gram at a time until it stops dissolving. However, I find that that takes a very long time. So I don't like to do 1 gram at a time. So I'm telling you right now, if anything else is too confusing for you, definitely just add 1 gram at a time, but there is a faster way to do it. So the faster way to do it is to use the bigger amounts first. And if you add too much of the bigger amounts, you then click undo and try a smaller amount. Okay, so I have the directions right here of how to do that, and it'll also be in the recording, and you can take a picture of it later when we go back to the whiteboard. Okay, but first start by adding the bigger amount. So add 25 grams. Okay, you'll notice it all dissolved, so we're good. So I'm going to add another one. Okay, so at this point, there's some that has not dissolved. So that means that adding this extra spoonful was a mistake. Smiley faces, everyone, if that makes sense. So now there's leftover that didn't dissolve. So this extra spoonful was a mistake. So what I'm going to do is I'm just going to click undo, and I'm going to go down to the next smallest amount, which the next smallest amount is the 10 grams. All right, so I'm going to add 10 grams. Okay, again, that 10 grams is too much. So what should I click? That 10 grams was too much, so what should I click? Yes, I'm going to go ahead and click undo. All right, and now I'm just going to go to the next smallest spoonful, which is the single gram. So 1 gram, add another one until it stops dissolving. Okay, so at this point I've added, again, too much, so I'm going to click undo. However, there isn't a smaller spoonful for me to use, so this is going to be my final answer. So after I click undo for the last time, this one right here is my final answer. So this says 30 grams, so 30 grams right here would be my final answer for 0 degrees. Smiley faces, everyone, if that makes sense. Again, if you need to, you can add 1 gram at a time. I'm just telling you, it's going to take you a long time to click 1 gram 30 times. Okay, this one was for 0 degrees, which is the cold one. Okay, again, don't copy this data because this is for the first chemical, which is one that you're not allowed to use. Okay, excellent, everyone. Okay, so now I'm going to go ahead, I'm going to reset this and set it to 20 degrees Celsius. All right, so I'm going to set it to 20 degrees Celsius now. Yeah, so you click on the red button to make it 0, the green button to make it 20, the blue button to make it 60, and the yellow button to make it 100. Okay, so now we're at 20 degrees. Okay, so I'm going to do the same exact process. Where did my picture go? Again, start with the biggest spoonful. Dolly, you should just be watching for now. All right, so eventually you'll do all of these with one of the other compounds, but don't do the exact same steps as me because you should be using a different compound. If you're using the same compound as me, that is plagiarism, okay? All right, so now I'm going to go ahead, I'm at 20 degrees, and I'm going to start again. So again, if you want to go faster, start with the biggest spoonful. Once you have too much, click undo, go to the smaller one. Once you have too much, click undo, go to the smallest one. Okay, one last time, give me a green check, everybody, if that makes sense. This process of how to make it go by faster. If that's too confusing, just add it 1 gram at a time. Just be aware it's going to take you a lot longer. Excellent. All right, so I'm going to add the biggest spoonful, 25. Going to add another one. Oh, that was too much. So I'm going to go ahead now and click undo and go to the 10 gram, the smaller one. So add 10 grams, add another 10 grams. That's too much. I'm going to click undo. And now I'm just going to add the smallest one, 1 gram at a time. Okay, so at this point, now I've added too much, so I'm going to click undo one last time. And since there is no spoon that's smaller than this is my final answer. So my final answer will be 38. You should do 10 grams and then 1 gram, Efren. So you go from biggest to smallest. So start out with 25s. Once you have too much, click undo, then go to 10s. Once you have too much, click undo, then go to 1s. Once you have too much, click undo, and that's your final answer. Okay, all right, so then you can do 60, right? So we can change this over to 60 degrees now, add our 25, add another 25. Let's see, just keep on going until it stops. All right, that was too much. I'm going to click undo, try adding 10 at a time. I didn't, I tried 10 first. You might just not be able to see it. It might be a little bit too small for you to see, but I actually did 25, then 10. Yeah, exactly. So you should do 25, then 10, then 1. You're correct, Efren. I think maybe you just missed it. but that is what I did. Okay, so I just added 10 and that was still too much, so I'm going to click undo and try adding one at a time now. You can't click both of them at the same time, Efren. So you can only click one at a time. Okay, once you start doing it, it'll make a little bit more sense. Okay, and again, these instructions right here are what you're going to want to have. Yeah, whatever you need to do, Efren, to get there, that's what you need to do. All right, so at this point I've added too much. I'm going to click undo, and there is no smaller spoon, so I'm going to type in 56 here. And then last but not least is my 100-degree one. Sorry guys, I'm trying to do this quickly, so give me a moment to do that. Okay, at this point I've added too much, so now I'm going down to 10 grams. Still too much, so click undo and go down to 1 gram until it stops dissolving. And again, this will be in the recording, so definitely if you get confused at any point, you can just come back to the recording. At this point there's too much, so click undo, and since there's no smaller spoon, that's my final amount, 78. All right, so go ahead everyone, give me a thumbs up now if that makes more sense. All right, again, those instructions should hopefully be helping you out. Cool. Perfect. All right, so that's our data, right? So for the NH4Cl, which you should not use, so for the example data, this is what I got, 30, 38, 56, and 78. Now you'll notice that I did not put any letters next to these numbers. You should never put letters because you'll mess up the graph. So don't put grams. The word grams is already included in the title. So you just put the numbers. Again, you should be getting unique data because you're not using NH4Cl. So you should get totally different data. You can use any bottle except for the first one. Exactly, Dree. So you can use the second, third, or fourth bottle, or sorry, second, third, fourth, or fifth bottle. Just do not use the first one. And then make sure that you click enter. So a lot of you are losing points, just so you know, on this last box because you type something in and then you don't press enter and it doesn't save it. So make sure you always press enter so that you actually save that last box. Smiley faces if that makes sense. I have that reminder here, but always click enter out of your last box so that you get credit for it. Okay, now what you're going to see here, everyone, is you are going to see that your graph has automatically populated for you. Okay, so it's automatically updating for you. And this is what you can see here. Now the thing is, some of these, for all of the other compounds that you use, this straight line is not going to work very well for predicting what you're going to be doing for your question number 4. So basically the trend lines for all the other compounds for the most part do not line up with the dots correctly. So this is the last thing that we need to talk about, and this one is going to be different than what we've done in the past. So what you'll need to do is you'll need to go ahead and double click on the trend line. Okay. All right, double click on the trend line, so this green line right here, okay? And down here, scroll down to where it says trend line and it says type, okay? So currently the type that I have is linear, and what your goal is to try to get this to match up as well. And you'll know that it matches up as well as it possibly can when this r squared is as close to 0.99 or even 1.0 as possible. Okay, smiley faces everyone if that makes sense. So we're trying to get this as close to 0.999 or as close to 1.000 as possible, this r squared value. Okay, so linear, you can change it to exponential, and you'll see it stayed the same, so exponential doesn't help me. You can change it to polynomial, and look, you'll see that at polynomial it turned into a 1, so polynomial is the best fit. Okay, so do not try moving average, but you should try linear, exponential, polynomial, logarithmic, and power series until you get this to either equal 1 or as close to 0.999 as possible. So again, you want it to equal 1.000, sorry, let me put this here, equal to 1.000 or close to 0.999 as possible. Okay, everybody, go ahead and give me a smiley face one last time if that makes sense. So this r squared value, you want to make sure your trend line matches up with that. Otherwise, what you will find is that for some of the compounds, the trend line does not match up with the dots at all, and it's going to give you an incorrect answer for your last question. Okay? Efren, did that answer your question? Okay, perfect. All right, so that's all you need to do for that. Now at this point, you're going to click share. Click Get Shareable Link, click Copy Link, and then go back to your lab, and that's where you put your shareable link. And that will answer question number 2, and question number 2 will be all set. So you can either right-click and click Paste, Or if you have a PC, you can press Control and V at the same time. If you have a Mac, you can press Command and V at the same time to paste your link in here. Again, make sure you follow these instructions from the share button. Do not give me the copy link at the top because that is your personal link and you will automatically get a 0 because I won't be able to see your graph. Even if you spend a bunch of time making sure it's perfect, you'll get a 0 because I cannot see it. So make sure you follow the directions correctly. Okay. Yes, Damien, this is all being recorded right now, so that will be in the recording. All right, so question number 3 asks you to make your conclusion. Okay, so you're going to say, right, our hypothesis was if temperature of water increases, then solubility of the solute will increase. Now, taking a look at my data, guys, again, your data may not be the same, so don't copy this. Okay, but I am going to show you an example of how I would answer this. So I would say that mine is supported, okay, by my data because my solid solute, which for me was NH4Cl, which is my example, okay, at a high temperature like let's say 60 degrees. So for mine, let's say I say 60 degrees for my example. It dissolved a maximum of, right, take a look at the number next to it, 56 grams, right? So 56 grams is my example. Which is less or more? So tell me in the chat box, is 56 a smaller or a bigger number than these colder temperatures? Is 56 going to be more or less solute than what we got at these lower temperatures? Yeah, 56 is a bigger number. So this is more solute than dissolved at these lower temperatures. So again, this is my example. So more than the amount that dissolved at the low temperatures. Because, for example, at the low temperature, like 0 or 20, so for example, let's say I say 0, okay, so 0 degrees, the maximum that dissolved was only 30 grams. So 30 grams was my example. And so this proves that as temperature increased, as I got to higher temperatures like 60 or 100 degrees, the amount of the solubility of the solid solute, the amount that dissolved, definitely increased. Smiley faces, everyone, if that makes sense. It definitely increased, right? We see bigger dissolving numbers here than down here. Bigger numbers here than down here. Excellent. Thank you, Noah. Looking good, looking good. All right, cool. So the last thing that you guys need to do, so again, this will be in the recording, or you can always take a picture of it from the recording if you need to. The last thing here is question number 4 asks you to use your trend line. Please make sure you use your trend line. Do not just try to make a prediction. All right, so I will be grading you based on how close you are to the correct answer, and there is a correct answer. So please, please, please use your actual trend line, okay? So using your trend line, you're going to try to predict how much of the solid solute that you chose could dissolve at 40 degrees. So what you're going to do is you're going to take a look at 40 degrees. Let me take a picture of this. All right. So you're going to take a look at 40 degrees, which is right here. Okay. You're going to go ahead and draw up until you get to your trend line, the green line. And from there, go straight to the left until you get to the solute line, okay? So if you take a look at this, everyone, each of these lines is 10 grams. So 10 grams, 20 grams, 30 grams, 40 grams, 50 grams. So since this is between 40 and 50 grams, a little bit closer to 50, I would say that this would be about 46 grams that I predict would dissolve. Smiley faces, everyone, if that makes sense. Okay, so again, start at 40, go up to the line, go to the left. Again, each of these dashes is worth 10. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120, 130, 140, 150, so on and so forth. Excellent. Looking good. And that's all you need to do, and you will be done with the lab. So it's very easy to gather all the data. And again, all of these instructions will be here for you. So I'm going to go ahead and pause that, come back over here. Okay. And again, this is the way to add the solute faster. So again, this will be in the recording. You can take a picture of it if you want to. But if you find this to be too confusing, add one at a time. Just know it's going to take you a lot longer. Okay, so it's much faster if you start with the big spoons and then go down to the smaller spoons. Okay, Looking good. All right, so that was our objective for today. We took a look at the relationship between temperature and solubility. The lab is technically due at 4 p.m., but I won't be grading it until the weekend, so you do have some time. We will enter zeros over the weekend, okay? So that being said, here's your last word. Thanks so much, everyone, and I will see you tomorrow. Bye, everyone.